Midpoint theorem. The statement is the line segment joining the midpoints of two sides of a triangle is parallel to the third side and is also equal to half of the third side. It is like this, explaining here in the diagram. E is midpoint of AB. So if E is midpoint of AB, this distance equal to this distance. F is midpoint of AC, so this distance equal to this distance. So it is given E is midpoint of AB, F is midpoint of BC. Then you are asked to prove this line EF. This line EF is parallel to BC, and also EF is half of BC. So there are two parts to prove. First part is to prove EF parallel BC, and second part is to prove EF is half of BC. So first we need a construction. Construction is like this. We will extend this line EF up to point say D, and we will draw this CD line parallel to EB or AB. CD parallel to EB, or we can say CD parallel to AB, and then we will take this triangle and this triangle, and we can prove the theorem. Now you see, I'll just mark this angle for convenience. I'll mark this angle 1, this one 2, this one 3, this one 4, angle 5 and 6. And then you see angle 1 equal to angle 4. Proof. First we will write proof. We are considering which triangle? We are considering triangle AEF and another triangle CDF. And in these two triangles, first we got this angle 1 equal to angle 4. Angle 1 equal to angle 4, you will mention here they are vertically opposite angles. 1 equal to 4. And then this distance AF is equal to FC, it is given. AF is equal to FC, it is given. AF is midpoint, so AF is equal to FC. AF is equal to FC, it is given. And then see, angle 3 equal to angle 5. Angle 3 equal to angle 5. How? They are alternate angles. Alternate angles. How alternate angles? You see, this line AB, this is line AB, and this is DC. They are parallel by construction, and transversal is this line AC is the transversal. So these two angles, that is angle 5 and angle 3, they are alternate angles, so they are equal. So what we got here, you see, angle side angle. So we can say by angle side angle criteria, the two triangles we are taking here, this triangle and this triangle. That means triangle AEF is congruent to triangle CDF. So if AEF congruent to CDF, then we must have AE equal to CD by CPCT, congruent corresponding parts of congruent triangles. CPCT. So AE is equal to CD. What we got? AE equal to CD, but AE equal to EB. AE equal to EB. This distance AE equal to EB, it is given. So from these two, you see AE is CD and also AE is EB. AE is CD and also AE is EB. So LHS equals, so RHS must be equal. What we can say? CD equal to EB. CD is equal to EB. Now you see, in quadrilateral, which quadrilateral? EDCB. EDCB. What we got? In this quadrilateral EDCB, we already got EB is equal to DC. I'll write here EB is equal to DC. We got this ED equal to BC, and also EB is parallel to DC. This is by construction. We have constructed like this, CD parallel EB, and EB equal to CD also, it is proved. We have proved here CD equal to EB. So what we got, you see, these two condition we got EB is equal to DC and also EB is parallel to DC. That means in this quadrilateral, this pair EB and DC pair of opposite sides, they are equal and also they are parallel. That means this EDCB is a parallelogram. If it is a parallelogram, this implies opposite sides must be equal. Opposite sides mean EB must be equal to, opposite sides must be parallel. That means ED must be parallel BC. ED must be parallel BC. You will mention here opposite sides of parallelogram. ED parallel BC. Now if ED parallel BC, obviously EF is parallel BC because ED and EF are the same line. So I can say EF parallel BC, and this is the proof for the first part, EF parallel BC. Now the second part is to prove that this distance EF is half of BC. Now in the first part we already have proved that this EDCB quadrilateral, it is a parallelogram, and if it is a parallelogram then opposite sides must be equal. That means ED must be equal to BC. ED must be equal to BC. You will mention here opposite sides of parallelogram. And also we have proved these two triangles congruent, and AEF congruent to CDF. These two triangles congruent, and this implies EF must be equal to EF corresponding DF. EF equal to DF by CPCT. Now you see, we have written here, we have already got here ED is parallel BC opposite sides, and ED equal to BC opposite sides of parallelogram. And you see distance ED you can write EF plus FD. EF plus FD, right side BC remaining same. Now EF plus FD, you see FD is same as EF again, equal to BC. So EF plus EF, ED is equal to EF plus FD. ED is EF plus FD, and EF plus FD, FD is same as EF. So what we can write, EF plus FD is again EF. So twice EF is equal to BC. This implies EF is half of BC, and this is the proof for the second part. So what we have proved, first part we have proved EF is parallel to BC, and second part we have proved EF is half of BC, and this is the complete proof for the theorem.